Problem number 48. Identify the species that is oxidized and the species that is reduced in each reaction. Write out two half reactions to show how many electrons are gained or lost by each species. So you're given three different redox reactions here. You should remember that oxidation is when an atom loses electrons, and reduction occurs when one gains electrons. To tell whether something is oxidized or reduced, you look at the charges on everybody. That's one way to do it. And if you spot someone's charge changing, then it's pretty easy to tell whether it's oxidized or reduced. So let's first look at the magnesium. Magnesium starts off as neutral, but it ends up as a +2 ion. Okay, so here it's a neutral, there is no charge, and it ends up as +2. So its charge is increasing. Okay, that's an increase in the charge. And when something increases its charge, that means it has lost electrons. It loses electrons. And so we're going to say that this is the one that's oxidized right here. The magnesium has been oxidized. And when something loses electrons, those electrons have to go somewhere, so somebody else is reduced. And if you look at the iron, it starts off as +2, but now it goes down to 0. So the charge is decreasing here, so it must be gaining electrons, and that's the reduction. Okay. So this particle is reduced. That one is oxidized, and this one is reduced. So let me move these other guys down here, and cut that. Let me just make a little bit more room. So the species that's oxidized, that's going to be Mg, and the species that's reduced, that's going to be not Fe, it's going to be Fe +2, because that's what it started as. So you have to put whatever it starts as. This is oxidized and that's reduced. So if you want to write the two half reactions, we can say that Mg turns into Mg +2, and so it loses 2 electrons. We need to write the 2 electrons explicitly. So this is the oxidation half reaction right here. And the reduction half reaction, we're going to start with the Fe +2, and we're going to convert into Fe. In order for that to take place, this guy needs to gain 2 electrons. So 2 electrons plus the Fe +2, and that allows it to turn into Fe. So here you can see the oxidation and reduction half reactions explicitly. So I'll just write that half reaction. And the reduction half reaction. Okay, let's do B. And let me copy down B. Okay. So here's B. Now similarly, you can see that the tin, the Sn, is going up in charge. Okay, so this guy, that's where oxidation is occurring. Whenever the charge increases, okay, that means it's losing electrons. That's why its charge increases. So that's oxidation occurring. And the charge is going down for the copper. That's where your reduction is. Okay, so who is it that's being oxidized? Well, it's this is being oxidized into that. So I'm going to say the oxidation, or the species being oxidized is the tin. And what is being reduced? Well, this is being reduced into that. So the copper plus 2 is being reduced. How about the oxidation half reaction and the reduction half reaction? All right, so we'll write what we have so far for oxidation. The tin turns into the tin plus 2, and the 2 electrons need to be placed on the right because oxidation involves electrons being lost. So this turns into that. This is a plus 2. Okay, so it has to have lost 2 electrons. And the reduction would be the copper plus 2 turns into copper. And the way it does that is 2 electrons are gained by the copper plus 2. Okay, last one. Let's copy down C. Okay, here we go. Now, C is a little bit more tricky because you don't see the charges, but you should recognize this guy over here as an ionic compound, okay? And in ionic compounds, the metals are the cations, and sodium has always got a +1 charge in ionic compounds. Let me write that in pink. So sodium is in the +1 column, remember. So here's all of these. Whenever these are in ionic compounds, they're +1 charged. Oxygen is in the -2 column. Whenever you see it in an ionic compound, it's -2 charged. So, oh, I'm sorry, you can't quite see that one anymore. So here it is. Let me bring this up. So I've indicated the charge on the sodium, and oxygen here is -2 in this compound. Okay, now what about the charges over here in these guys? Well, they are elements, okay? Sodium by itself is simply an elemental substance. It's a neutral substance. When it's part of an ionic compound, then it's +1 charged. But by itself, as an elemental substance, it's 0. So is oxygen. This is the oxygen element. Oxygen comes in the form of O2. So it's also neutral. Now that we've assigned charges to everybody, you can pretty easily spot who's being oxidized. Sodium starts off as 0 and it goes up to +1. That's your oxidation. And then the oxygen starts off as 0 and it goes down to -2. That's your reduction. So one more time, let's write the oxidation, also the oxidation half reaction, and I'll turn this periodic table off. And then the species being reduced, and also the reduction half reaction. Okay, so who's being oxidized? Well, the oxidation is occurring here, so this is being oxidized into that. So I'm going to say the Na is being oxidized. And who's being reduced? This time it's the O2 is being reduced into the O -2. So who's being reduced? I'll say it's the O2. So the oxidation half reaction, we have 4 sodiums And here on the right, this is the tricky part here. Okay, on the right, inside this ionic compound, these are sodium pluses. Okay, Na pluses. And you have a total of 4 of them. Okay, there are 2 of them per formula unit, but then you got 2 formula units. Okay, so you got a total of 4 of them. I know that's sort of tricky to see that, you know. Why don't you write it like this? You got 2 Na2 pluses. Well, that's kind of weird to write it like that, because the Na2 doesn't have a plus charge. Okay, each of the Nas is positive 1, and you have a total of 4 of them, so that's not what you would do. Anyway, so for 4 sodium atoms to turn into 4 sodium plus ions, they must have lost 4 electrons. So here they are, and you can be sure that 4 electrons will be gained in the reduction half reaction. So what's happening for the reduction? You got oxygen molecule turns into 2 oxide -2 ions. Okay, so you start off with a single oxygen molecule. Now you got 2 oxide anions. So here, these guys have 4 extra electrons. Okay, that's a total of, you got 2 -2 charges. It's a total of -4. For this neutral molecule to turn into something that has a -4 charge, it must have gained 4 electrons. So this part C is kind of tricky, okay, for this one right here. But that's how you do it.